Some STEM projects we have done include, at infant level, we will see two examples here. The first project we see is from Mr. O'Connell's class. For this, the class were doing a unit of work on farming in the future, which was brought into Asher also. Here, the children had to problem solve to design farm machinery in the future. Scientific concepts such as growth and change, conditions for growth and environment were also explored. The children engaged in the engineering design process for making their machinery for future use on the farm. You can see that one group designed and made a flying tractor. This was designed, constructed in the construction area and then brought into the small world area for use there. In the sand area, there was a corn thresher and a corn mill. The children watched a video on threshing, combining and milling. And following on from that, they went about designing, inventing and building their own machines, all overlaid with lots of inventive dialogue, chatter and machinery sounds making. If you were to ask a child about their invented machine, they were able to describe what it was doing. This image shows where the teacher and children planted cress in the role play area, pretending it is corn and now it is ready to harvest. There wasn't a crop of corn as well watched that week apparently. They even made scarecrows. What farmer wouldn't want one of these? Great designing and making was on show with this boy exhibiting his future farm machinery, the flying tractor. I hope you like his attempt at spelling. This was a high interest activity, totally engaging and absorbing, and he wanted to communicate what type of tractor it was, and he succeeds in doing so with his approximate spelling. Now, isn't that real, connected and meaningful learning? The next project we see is one completed by Miss Doran's infant class. Overnight they had a visit from a mischievous leprechaun. He caused lots of mischief and was very fond of anything green or gold. It was reported in the local Wexford Guardian newspaper that he was causing lots of mischief leading up to St. Patrick's Day. Here, Miss Doran presented a problem through use of a scenario and real-life situation. The children had to figure out a solution to this problem, and their plan was to design a trap to catch the naughty leprechaun. In groups, they designed and constructed this trap to capture him, and evaluated and redesigned their traps when the leprechaun evaded capture. In this picture, we see the children in inventive mode, designing and drawing the traps they might set up. They drew some super plans to try and nab the mischievous Larry. In this picture, you can see the basis on which the trap works, but the question is, will Larry spot the purpose of that pencil? There were a great variety of traps, and the children were able to review each other's work, their designs, and comment as to why some were better than others by role-playing Larry and how he might behave and the things he might spot. This is a great project completed by Miss Maguire's second class. The class were learning about the Titanic in history, and there was a very obvious problem here. In groups, the children had to design and make a large ocean liner that would stay afloat. Science concepts such as floating and sinking were taught explicitly and were woven throughout the engineering design process also. In this picture, you can see the group of naval design and construction engineers in conversation and hard at work. In this image, we see the lads carrying out their floating and sinking experiments, investigations, exploring density and mass, and making observations and recordings. They predicted and recorded if objects were positively or negatively buoyant. Real hands-on learning. Take a look at some of the final exhibits. Next, we see an example of work from Miss Redmond's 5th class. This activity was very much child-led and also developed the concept of fair testing, with the children working in small groups. They had to create the bridge structures with a limited amount of paper, so they had to be creative and think strategically about simple structures, including concepts such as height and span. This evolved then to include testing the bridges for strength, which required a systematic approach to investigate the best combination of spans. In this picture, you can see the children immersed in constructing their paper bridges. Next, they carried out some fair testing investigations to see which bridge was the strongest and to determine the design that can therefore carry the greatest load. The strongest bridge was designed and constructed by Jack, Jake and Emma. Finally, here we see an example of STEM being completed incorporating Lego. This is Miss Mara's 6th class, who are accustomed to using the Lego We Do Too packs. This was an open-ended project that Miss Mara found online, where the children had to design and make their own invention. Their invention was then given tests and tasks such as crossing a tightrope. The pictures illustrate how the children problem solved to create their invention, revised it to give it arms, and then coded it so that it could move itself across the rope. In this picture, you can see the two lads deeply involved in figuring out and problem solving. Here, the tightrope has been attached above the floor of the canyon. Now, can the boys code Robbie the robot to pull himself across the canyon to the other side? After much trial and error, studying the code to see why it was not operating to the inputted commands, the lads finally debunked the code and off went Robbie Robot across the canyon. Eureka moment. Other great projects completed included real-life problems, such as designing snowplows to help out during the snow this past February for Storm Emma, rescuing pandas, designing of dump trucks to deal with waste problems. Lots of schools are posting their work now, and these provide great ideas that can be adapted to your own context. Follow my own school on Twitter at St. Aidan's PS.